Hello everyone, this is my demonstration of a Weebots robot planning its path to a goal pose in a world with a known map, and this world also has noise in it. So just as before, it has noise in the inertial measurement unit, also down here into the position sensors on the hinges, and also noise in the distance sensors. So all of this this is meant to show that the noise shouldn't really do a lot since we're planning our path out before we get to the goal. So the only real place for error is during the execution of it. So since I showed this last time for cell 1, let's do cell 6 as the goal cell to end at, and we'll say instead of facing north, we'll say it has to end at west. So it should end up here, and it should be facing towards the west whenever it ends. So to begin, we'll put a 2 right there just as before. Should put a 3 at both of those ones. Then since there's 3's here, you can put a 4 there and a 4 there. It does. Spots available, put a 5 there and a 5 there. It does. Put a 6 here and a 6 here at this corner. Since this is a T section, it has a left and a right available, so we should put a 7 there and a 7 there. And the 6 down here, we'll put a 7 here. And it's pretty easy to see that this is the path right here is the shortest one. This is kind of out of the way in comparison, but you still have to finish it anyway. So we should put an 8 there, but since this one has a 7, we'll put an 8 here as well. And since there's a 7 at this cell, we'll put an 8 here also. Okay, so like I said, you can see that there's the shortest path. This one did not complete, so this path does not work. This would have been a 9 and it would have ended at 10, so 10 is less than 8, so this is obviously shorter. And this one right here, it ended up dead ending right here anyway. It can't go anywhere, it just hits 8 there and can't move. So since we have our little path of from 8 to 2 again, we're just going to put together our plan. So it should move left 3 times. You see it does. And then from there, we're it's from 6 to 5. So 5's value should be go forward to 4, and then 4's value or move should go forward to cell or the cell that has a 3 in the value. And so there should be 2 forwards, and there is. And then the last move should be from 3 to 2, and you can see that there it is. So there's a right from 3 going towards 2. And the only thing left to do is to execute it, so we'll do that. And so it's going to head on here, going and doing its left, so I'll speed it up since it has to face north every time. And then here's where it'll go on through, should go straight. Remember, we're trying to face west, so it's going to face north right here. So it made it to its spot right there, it marked it as visited, and now it's going to finish facing north. It finished facing north, and now it should go to face west. Oh, okay. And that's the noise in the world. So it went and did that, but it made sure that it was facing north, and then it went and turned left to face west, and it ended up at grid cell 6, the goal cell, and facing west, the goal direction. So it reached there, and we planned out our path in 32.5 seconds and executed in that time too. So thank you for watching.